Now let's work on some examples involving limits with trigonometric functions. There are some equations that you need to know. Here's the first one. The limit as x approaches 0 of sine x divided by x is equal to 1. So now let's confirm it. A nice simple technique to evaluate any limit, if you have access to a calculator, is to plug in a number that's very close to what x is approaching to. In this case, it's approaching 0, so let's try 0.1. Make sure your calculator is in rating mode, by the way. Sine of 0.1 divided by 0.1, that's equal to 0.998, which is very close to 1. Now let's try 0.01. Let's see what's going to happen. So this is going to be 0.99998, which is even closer to 1. So we know that this equation holds true. Now, there's another formula that you need to know. It's the limit as x approaches 0, 1 minus cosine x divided by x. This is equal to 0. So to confirm it, let's plug in 0.1. Let's see what number we're going to get if we do this. So this is going to give you 0.05 approximately. It rounds to 0.05. Now let's try an even smaller number. Let's try 0.01. So this will give you 0.005. Notice that these two numbers are not the same. They look similar, but this number is 10 times smaller. It's getting closer and closer to 0. Just to confirm it, let's try an even smaller number, 0.001. So this will be 0.0005. So as we can see, as x gets closer and closer to 0, notice that y approaches 0 as well. So this equation holds true. Now let's work on this problem. What is the limit as x approaches 0 of sine 5x divided by x? What is that equal to? Now keep in mind, we know that the limit as x approaches 0 of sine x divided by x is 1. For those of you who quickly want to see the answer, it's going to be 5x divided by 1x, which is 5. But you got to show your work though. But that's just a quick way to get the answer for those of you who want that. What you need to do is multiply the top and the bottom by 5. And we're going to take this 5 and move it over here. So this is equal to the limit as x approaches 0, sine 5x divided by 5x times 5. Now what we're going to do is we're going to use substitution. Let's say that y is equal to 5x. So notice that the limit as x approaches 0 of 5x, that's equal to 0. That's also equivalent to the limit as y approaches 0 of y. Since y is equal to 5x, as x approaches 0, we know that this limit becomes 0, and this is also equal to 0. So therefore, they're equal to each other. So therefore, as x approaches 0, 5x becomes 0. And 5x is y, so y becomes 0 too. So by making that statement, we need to realize that we can now change the limit to this expression. We can say the limit as y approaches 0, sine y divided by y times 5. So all we did is we substituted 5x with y. Now we can use the formula. If the limit as x approaches 0 for sine x over x, if that's 1, then the limit as y approaches 0 of sine y divided by y must also be 1. So this is going to be 1 times 5, which is equal to 5. And that's the answer. So what you want to do is you want to make these two values the same. And then you could replace it with a letter like y. And then evaluate the limit that way. Let's try this problem. What is the limit as x approaches 0 of sine 2x divided by 5x? What do you think the answer to this problem is going to be? It turns out that it's just 2 divided by 5. You can literally see it. But now let's show our work. So what we need to do is multiply the top and the bottom by 2 over 2. What I'm going to do is switch the 2 and the 5. So we can rewrite it as the limit as x approaches 0, sine 2x divided by 2x times 2 over 5. So I just switched the places of these two numbers. 5 times 2 and 2 times 5, they're both equal 10. So the value is still the same. Now, once these two values are the same, you can use substitution. So we're going to let y equal to 2x. So therefore, we're going to change our expression as the limit as y approaches 0, sine y divided by y times 2 over 5. Now we can use that one identity where the limit as x approaches 0 of sine x divided by x is 1. So this expression in blue is also equal to 1. So our final answer is 2 divided by 5. But now you can show your work. This is how you're going to show your work if you have to take it on a test. But if it's a multiple choice problem, you can clearly see that it's 2 over 5. Now what about this one? What is the limit as x approaches 0 for sine 7x divided by sine 3x? Feel free to pause the video and work on this problem. So just by looking at it, we could see that it's 7 divided by 3. But let's show our work. So what we're going to do is we're going to multiply the top and the bottom by 7 over 7, 3 over 3, and x over x. So now let's separate everything. So I'm going to leave the sine 7x on top. However, I need to put 7 and x. I need to move this over here. I want it to be below sine 7x. Now I need to do something with the sine 3x. So I have to keep it on the bottom. But on top, I want 3x above it. So I'm going to write it here. Now what I have left over is 7 over 3, which I can put it in this third fraction. So every number has been accounted for. I just simply rearranged everything. So let's say that y is equal to 7x, and let's say another variable w, let's let it equal to 3x. So we're going to have the limit as y approaches 0, sine y over y. So that's for this portion. And then we're going to multiply that by the limit as w approaches 0 of w divided by sine w. Since 3x, we set it equal to w. And then we're going to multiply everything by 7 over 3. So therefore, this becomes 1. This expression is also 1. And then times 7 divided by 3. So the final answer is 7 over 3. And that's it. Let's try this one. The limit as x approaches 0, tangent x divided by x. What do you think the answer to this problem is going to be? Well, tangent, we know, is sine divided by cosine. But first, let's rewrite it like this. Let's separate x and tangent x. And now in the next step, let's replace tangent with sine over cosine. So this is equal to the limit as x approaches 0, sine x divided by x. I'm going to switch these two. Multiplied by 1 over cosine x. Now, as we apply the limit, sine x over x, based on the formula, will change to 1. Now, what about cosine? Cosine of 0 is 1. So as x approaches 0, this becomes 1 as well. So the answer is 1. And you could see it. Tangent x and sine x are very similar. 1x over 1x is 1. Here's another example. Let's say if we want to find the limit as x approaches 0 of tan 4x divided by 3x. The answer is going to be 4 over 3, but let's prove it. So first, let's convert tangent into sine over cosine. So this is going to be sine 4x divided by cosine 4x times 1 over 3x. Now we need to multiply the top and the bottom by 4 over 4. So we need to take x and 4 and move it under sine. So this is equal to the limit as x approaches 0, sine 4x divided by 4x times 1 over cosine 4x times 4 over 3. We had a 4 on top and a 3 on the bottom. Now let's say that y is equal to 4x. So this becomes the limit as y approaches 0, sine y divided by y times 1 over cosine y times 4 over 3. Sine y over y will change into 1. Cosine 0 is 1, so the final answer is going to be 4 over 3. What about this one? The limit as x approaches 0, 7 times 1 minus cosine x divided by x. What's the answer? Now, if you recall, the limit as x approaches 0 of 1 minus cosine x divided by x, that's equal to 0. So to show our work, we're going to separate 7 from everything else. So we know this portion here is 0. So our answer is going to be 7 times 0, which is 0. Now let's try a different example. What is the limit as x approaches 0? Sine squared x divided by x. Take a minute and try that problem. So sine squared is basically sine x times sine x. So we have sine x over x times x. Now let's separate this into two limits. The limit as x approaches 0 of sine x divided by x, we know that's 1. The limit as x approaches 0 of x, well, you can use direct substitution, that's going to be 0. So 1 times 0 is 0. So this is the final answer. Consider this one. The limit as x approaches 0, sine of x squared divided by x. What's the answer? Well, what we need to do first is we need to multiply the top and bottom by x. So we're going to get the limit as x approaches 0, sine of x squared divided by x squared. So we combine these two together. And then we have an x on top left over. Now let's use substitution. Let's set y equal to x squared. But before we replace x squared with y, let's write this expression using two limits. So now on the left, we can say the limit as y approaches 0, sine y divided by y times the limit as x approaches 0 of the function x. On the left, sine y over y will change into 1, and the limit as x approaches 0 of x is 0. So the answer is 0.